This conference will now be recorded.
Right. Hi guys. So to introduce myself Ravinder. I'm working as MongoDB DBA close to 9 years, 9+ years now. I'm working as SQL DBA 18+ years, and I'm working on Postgres, MySQL, MariaDB, even Azure and AWS cloud technologies also. This is my technical background. I'm working as a technical lead in my current company, so I do handle all technology escalations. So that's how I get in touch with all the technologies, and I cover all the real-time scenarios during the class as well. This is about myself, a little introduction. Let's talk about the today's agenda. Today's agenda is all about NoSQL technologies, and under NoSQL technologies, how MongoDB outshining in the market. What are the use cases it is fulfilling? All that we're going to discuss. So first is what is NoSQL and why NoSQL is required. So basically, if you look at RDBMS technologies are introduced way ago, like 1960s, Oracle started till they are outshining. But there are certain use cases RDBMS cannot really do the job. There, the NoSQLs are doing it. So if you look at RDBMS are very sophisticated products, but they are only structured. They only support the structured data. Non-structured data it won't support generally. So they're designed for the structured relational data. NoSQL means no relations, nothing, absolutely no relations at all. So I'm going to discuss the architectures absolutely. Some of the features that RDBMS cannot support, the NoSQL is supporting. That's how the NoSQL products are outshining in the market, in fact. What are the benefits we do have compared to RDBMS? This is a major agenda of today's class. And what kind of RDBMS systems we have, or what kind of NoSQL systems we have, what is the terms we use it. Let's just an introduction only. Today's all discussion is all about introduction, like what is NoSQL technology, how it is giving the better benefits compared to RDBMS. We will compare with RDBMS and NoSQL and MongoDB. That's how the entire agenda will end up. What are the different types of NoSQL products we do have in the market, and what is a cap theorem, and where the MongoDB starts into the cap theorem. We're going to talk about that as well at the end of the demos today. So let's talk about MongoDB. MongoDB is a NoSQL, right? NoSQL is introduced way ago, like 1998 itself by Carl Stroji. It used to be called as a file-based database systems. In fact, that time there was no good response from the market for the NoSQL technologies. If you talk about like 10 years to 15 years ago, we got the smartphones. If you compare with now, we are into 2025. If you talk about 2007 and 6 times, we were not having a smartphones. We were having the QWERTY keypad where you can make a call, you can receive a call, you can't generate data. Right now everybody have a smart device, everybody can generate data, and data is versatile. Someone is loading the comment, someone is uploading the video, someone is uploading the photos, Instagram, if you take it as an example. So data is absolutely versatile nowadays, where RDBMS cannot serve that kind of purpose. So nowadays the data generation became versatile. Now the NoSQLs are outshining. In the olden days, before 2010, I'm talking about, RDBMS were sufficient because there is no devices people were generating it. There were application servers where people were used to feed the data, and the backend data used to be structured data. It used to serve the market purpose. But now it is not serving the purpose because of the data versatility became uh, big popular in the market, because all Play Store apps, if you download a Play Store app, almost all the Play Store apps are running on the NoSQL technology only, not on the RDBMS, because of the nature of data you load into the Play Store apps, in fact. Okay. NoSQL also, we do have a lot of different group of products. I'm going to give a little bit of information about other products within the NoSQL along with MongoDB. There are many other products, but compared to other products, MongoDB is really getting implemented in the market compared to other RDBMS products. Right. So compared to, let's talk about, before I come to the slides, I want to give you some background information so that I can talk about every point in the slide what I have written. So try to understand. If it is RDBMS, what generally happens in the RDBMS, you stand up a very big machine. Within a big machine, you will have a data directory, log directory, tempdb directory, whatever it is, you will have it, right? If you have more data, you'll create more data directories also and stripe the data, basically. if it is RDBMS. So you'll attach more CPUs to process the data. As data is growing more and more, you give the more compute power so that it can scale the data. But here in the RDBMS, you can't scale huge data here. Example, I have a 5 TB data, assume a case. 5 TB data in a single server. So if you have to do the rebuilding, reorganizing indexes in a during the weekend, you can do it. 5 TB is okay, manageable. If it becomes double, 10 TB, 10 TB single database, you can't do the rebuild reorganize index within a given maintenance window. It takes even longer. 10 TB means definitely it is going to take longer. You have to target table by table, week on week, so that you can make the indexes intact, like they get updated. Rebuilding reorganizing can be done. So here when the data becomes huge, you can't do the maintenance activities over the given one single window. It's not possible. And there's such a volume of big data in the RDBM system. If you can't do the maintenance within a week, then what happens? Data tables will be fragmented. If they get fragmented, you see the unnecessary data will be pulled out, right? You will see that data fragmentation can read the unnecessary data, so that will degrade your performance down the line. If you have a huge the server is processing your data, but it is taking longer because of the indexes are not able to update it time to time because of the volume of data having in a single system, right? So this is a limit. It is going to be limit. There you when you have a huge compute power also, the data is growing and growing. You can't do the maintenance activities. That will be a big drawback in the RDBMS. In fact, when it comes to the NoSQL, the architecture is different. The NoSQL architecture follows the horizontal computing model. This is going to make you more flexible, irrespective of amount of data. You can really scale. You can do the rebuild index, reorganize index, whatever you want to do. You can do it because you're not putting all your data into one system. You are going to distribute the data into a lot of systems. In fact, let me explain this architecture quickly. Then we'll talk about it. So let me draw a few things. So this is about just information only. We're going to configure this technology in and out, and I'm going to explain with the live configuration implementation. But try to understand now the difference you need to understand. These are all applications, and these are all router or mongoose. We'll call it as mongoose or router in the configuration. These are all config server, which maintains the entire cluster metadata. Config servers, and this one is replica one, replica set 1, okay, replica set 2. So just try to catch the architecture. I'm not going to finish anything. How it is going to scale when you have a huge data, that's what is the point of discussion. So application will contact the router server will contact the config knows what are the replica servers you have in the background, in fact. So here if I load example 100 GB data, 100 GB data I'm loading from the application, then automatically your 100 GB data will be distributed into multiple systems. 25 GB here, 25 GB here, 25 GB here, 25 GB here. It will distribute automatically. So you are writing into 4 different servers. Each 100 GB got distributed and into 4 different servers. You are writing parallelly. You can read parallelly. Both can happen. So the 25 GB again is one portion is protected with the multiple copies. If this goes down, this will pick up the primary role, and the cluster will be available. You don't see the downtime, in fact. So here when I distribute the data, the more data you have, it still you have in a different systems, not in the same system. I can do the rebuild. Your 10 TB become 2.5 TB, 2.5 2.5 TB in each server. So you can easily do the rebuilding reorganizing indexes, though data is becoming too big. The maintenance activities, availability of the systems, and fault tolerance also is very high in the NoSQL technologies. Along with this, if you talk about RDBMS system, one of the I'll take SQL servers as an example. Let me take this an example. I'll show one thing point by point, guys. Many points we're going to try to understand. Cloud server. So I'll take the on-prem. So any database I'll go up to, I'll pick up one of the table. I don't have a table, so I'll create one table quickly just to show that. Create table student. So just try to catch up the differences. In fact, I'm going to only talk about differences today, not much. uh, so I'm defining three fields here. Okay, so I'm going to load the data into this table. Within that structure, what I defined, select, insert into, I'm trying to insert the data, insert into student values. Okay, so I'm going to give it here. Okay, Naresh, Hyderabad. So what I'm trying to do here is I define a structure: s number, s name, s address. So number is integer, name is a string, address is also string. If I'm trying to load the data, it will accept. But if I try to add a phone number of the user, it won't accept. Why it won't accept? Because I did not define the structure. I did not define the fourth element, right? Fourth field I did not define. When you did not define it, saying that column name, number of supplied values are not matching the definition. Whereas NoSQL, come to this NoSQL MongoDB server, database creation is on the fly. I'm going to use a database called lab. It is not there. So what are the databases we have right now is only default system databases. I can use a database name. On the fly, it will create database name. Everything is on the fly. Dynamic schema, no schema definition at all. So db.student.insert into the lab. I did not create a student table, but I'm going to load the data. It will take everything on the fly. You don't have to define anything. Okay. Sorry. So here you don't have to define anything. So Naveen, I'm loading this record. It accepted. Now I'm going to load second record. The second record will be I'll load the address. Address is Hyderabad. Okay. Third record I'll load it. I'll tell you the difference. So basically, we're going to talk about the main differences between the RDBMS and NoSQL today for today. Phone number. I'm adding the phone number. It accepted it. Now I'm going to give the email address. So naveen@gmail.com. It accepted it. Now if I go and read data, so if I'm reading the data look like this. First record having a two fields, second record have a three fields, third record has a four fields, fifth record has a fifth fields, five fields. So I did not define anything. It takes data in any format, in any structured, semi-structured, unstructured, any kind of data. It won't reject simply. Everything is dynamic. You can load any format data, the MongoDB will accept. All NoSQLs will accept, in fact. Data, it does not look for the data, what you are putting into the system. You're just giving and giving the data, everything will load automatically and dynamically. You don't have to create the database, you don't have to create the object, you don't have to define the structure, nothing absolutely. Entirely dynamic. It follows the dynamic schema model that makes more outstanding this product in the market. In fact, nowadays if you talk about any social media, all social media platforms are running on the NoSQL platform only, not on the RDBMS. Because RDBMS, you have to define the structure first, then load the data, then only it accepts it. So you have to first develop the backend, then front end to adopt the data. But in the NoSQL backend, you don't have to develop anything. It's a fully automated. Anything you submit, it'll accept it. In fact, okay, there will be bad thing. If it is accepting any data, it's not a good thing for certain cases like electoral data, Juma case, election data. If a person age is less than 18 years, it should not accept the data, right? So that kind of things we have to create the validation separately. I'll give a condition. I'll write a condition on the field. If this field is following this rule, take the data, else don't take the data. So field level rules you can define. That is called schema design. Field level rules, not entire table level. A field, if the field is more than this, less than this, or following this condition, then only accept the data. That level of conditions you can write on a single field. That's something we're going to talk in the schema design, not now. You can control the data if you want to keep some rules on the particular field, in fact. So first difference is NoSQL pick up any data, whatever the format it is. RD members does not. This is a one important difference. Next difference is if your database example, I have a 10 TB database, 10 TB database in SQL Server, 10 MB data is corrupted, 10 MB data, which means equal to 1000 pages in SQL Server. If you talk about SQL Server, 1000 pages are corrupted, that will be marked in the MSDB. Your database, 10 TB database will be down because of 10 MB data corruption. If data is corrupted, it can't repair on its own. In fact, you have to repair explicitly if you want. Your entire database will be down just because of 10 MB data corruption. Okay. When it comes to the NoSQL, your one entire replica is down. Entire replica is down. Assume a case, it won't go down generally, but if it goes down also, still you're operational with available data. It will not go down just because of one replica is down. It will operate with the 75% of the data. If your operations are within this 75%, you will operate all your operations without any issues. If you are writing or updating anything, this one, your operations will be down because this segment is down. But if I'm loading the new data, it will not be problem. It will insert the data here automatically. When this comes online, it will balance the data automatically there. So here what I mean, in RDBMS, 10 TB database, 10 MB database is making the entire database down. In the NoSQL, 25% of the data is down, live data is down. Still you can operate. Whatever the data is available, you are able to operate. You are going to load the data because whatever the nodes are available, it loads the data. Write operations, I mean insert operation will not face any issues. Delete operations, update operations will face the issues if your condition is falling in the data range which is down. But rest of the operations will progress. So what it is giving is, it is not going down entirely just because of a portion of the data. It is giving more availability to the system compared to RDBMS. Compared to RDBMS, every RDBMS system, a portion of data is corrupted, entire database will be down. There is no option to, you can make it online unless you manually repair it. There is no way. So it gives more availability of the server, more availability of the data. You can say that, not server, availability of the data to the business compared to RDBMS. So any questions here? Let me know. If you want to ask, you can ask anything at any point, because it's not one side. Don't keep it to one side. If you have a question in your mind, please open up. Right. Next point of discussion is write capacity. In the RDBMS, you will write into one server. If it is SQL
Ravinder, I
Server,
have one doubt.
yeah, yeah, God.
How MongoDB maintains the integrities? Like one of the see, if there is 100 GB data, it is going to
Mm,
segregate multiple shards, right? If one
mm,
of the shards goes down,
mm.
how it will integrate uh,
It,
acid
it,
properties? It will
it's
this
not.
thing.
It does not follow the ACID anyway. But anyway, it is not losing the integrity. How it is not losing is, your server is down. It is not corrupted. Okay, you can make the server online. When it comes online, it will pick up the data. It is if it is corrupted, that's a different story. Here also. But what I mean here is, your data, 25% data is down. Still 75% is operational and available for the live business. 25 data percent of data, when the server comes online, it will be operational again, that 25% also. If this corrupted, you have other copies too to protect the data. Okay, you have the high availability. One corrupted, you have other copies to protect. So this concept is, it gives a real, we are not operating any out of integrity of the operations. It is down at the moment, it is down. We are not touching the data, we are touching what is available. Down is down anyway. Okay, but once it comes online, it will be operational, business will see the data. But when it is down, that data what it is you're trying to operate, that will be down. You are not going out of integrity. It maintains the integrity at the end of the day. If it is down, that data is, you have to maintain a different service. You do the failover manually. If it is not done, it will be done automatically. Failover, this will take the primary role. Assume a case all are down because of some infrastructure issues. Something went wrong in the Hyper-V layer or whatsoever happened. the entire server group in the replica set is down, still you're operational. It doesn't mean that it is completely gone. Okay,
Okay,
when
got
this
it.
comes online, you'll operate it. Okay, it is that way. Right.
Uh,
uh
Hi Ravinder.
yeah, good.
Uh, can you tell me about that Mongoose and router?
Mongoose router is something your applications will connect this one. Okay, it doesn't know your backend servers. You write here only, everything will be visible here. Your databases, your connections will come here. It will connect to your config. Config maintains the entire cluster metadata information. How many servers you have, how many databases you have, how much data is there in which shard. It is only information. So that information will pick from the config server. It go to the backend server, read the data, write the data according to the metadata what it is finding it out. So router is like a listener kind of thing. It's a logical name for us.
Okay.
Okay, anyway,
Yeah.
I'm going to configure this entire setup. I'm going to show entire data flow, how it happens, how data distribution happens. We can see live everything. We're going to see live in our sharding module. Anyway, this is a sharding. In fact, we call it as this technology as sharding in the MongoDB. So this is kind of interface. This is where the all applications will come and hit. In fact, all applications will the router servers. Router server will go to the config to get the cluster information and then operate on the cluster. Okay, that is the role of the mongoose or router. Okay, next discussion is, if example, okay, if it is rdbms system, you can write into one system only at any given point. If it is SQL server, you will have one more standby. Like in the AG, if you talk about AG, you will write into primary server, it will sync into secondary. Okay, it will sync into secondary server. You can keep multiple secondaries if you want. You can keep multiple secondaries. All secondaries are readable, not writable. You can only write into one copy only at any given point in the SQL server, except Oracle. Oracle has one good concept called rack. In fact, what exactly rack does, so you have multiple servers, you can write into multiple servers, but one volume at the end, all of the servers are attached to one volume only. Okay, applications can write here, 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 but your choking point is here, one point, one storage, where it gets written into multiple servers, all will come to one value. So it is a single point of failure. If this is gone, you're gone completely. So no RDBMS giving the right scalability like RDB, like NoSQL. If it is a horizontal computing model, okay, uh, the RDBMS is called vertical computing model. Vertical means you give the more power to one system to scale with more and more data. When it comes to the NoSQL, you give the more power in terms of machines. If data is not manageable with the 4 shards, I'll add one more shard. Okay, once you add the shard, 25 GB, 25 GB, it will become 20 GB, 20 GB, 20 GB automatically. You just run one command, it will get added one more shard, and then data will distribute automatically to new shard automatically. You don't have to do anything. Just add the one replica, the cluster will migrate the data automatically. You don't have to do anything. So write capacity will be more, read capacity will be more, because single operation served by multiple servers. If you talk about Facebook, Twitter, any social media, did you ever seen that the platform going down? You never see. Why you never see? And you don't see the latency also. Why? Because single request served by hundreds of servers in the background, not by one. That's why, irrespective of amount of data, irrespective of number of connections, your speed of data, the delivery of the response will be very, very high in the NoSQL. It's not hitting one system to get the data, it is hitting lot of servers to get the data. That's why you are not getting slowed down. Though it is the data is huge, you can absolutely full huge amount of data on the real good speed. The performance will be very high. Question?
Yeah, Ravindra, hi. Wasim here.
Yeah, question.
So this config server holds all the
Metadata.
metadata about the replica sets, right? So
Correct.
does this config server has its own kind of a replica or a
Yeah,
standalone?
it is also
Okay.
replica. One replica. It is also replica. Everything replica means if this goes down, this will pick up the primary role. It maintains, it copies, continuously sync the data. If this goes down, this should pick up the primary role to get the metadata. This is one replica, of course.
Okay, thank you.
Yeah. So I'm trying to figure point by point I'm discussing here. One is an NoSQL dynamic schema model, takes the data in any format. You don't have to define anything. Absolutely takes structured, I mean semi-structured, unstructured, any kind of data. Okay, on the fly. RDBMS is not like that. It's a rigid platform. Second point is RDBMS is absolutely dependent on your one single copy, and if one of the small portion of the copy is corrupted, your entire server will be down. Whereas in the NoSQL, 25% of your data is down at the moment. You're still operational with the 75% of the data, whatever is available. Your insert operations will go on. Update operations, which is update and remove, can be down because it is trying to look for the existing data, right? If whatever the condition your connection is looking for the down data, those cannot work, but the rest will work. The fourth thing is write capabilities, read capabilities are more. The more, why? Because you are not hitting one system, you are hitting hundreds of system, group of systems. One query is served by parallelly by multiple machines. You can scale, you can absolutely scale because you are not hitting one system for your bulk data. It is multiple server serving. You are absolutely getting the performance because all servers are parallelly working for you to give the chunk of data what you're asking for. Okay, this is a third thing. Fourth thing is open source. All RDBMS are almost, except this Postgres, MySQL. MySQL is a very limited. They are lock lot of features anyway after Oracle purchased the MySQL. Postgres is absolutely, I'm working on Postgres, MySQL, MariaDB very in detail. Postgres I know in and out. So Postgres is something absolutely community driven. It's not a licensed product. You have a EDB anyway, enterprise version. That is something developed by someone. So they work on the Postgres platform only at the end. So all RDBMS are, like most of the popular RDBMS, MS SQL, Oracle, these are all licensed. You have to pay and use it. Not a small amount, very huge amount you have to pay. So this cluster is also available in the community edition, free edition. You don't have to pay anything. We are running 50 TB data in one cluster in the community edition. We are not paying single penny for the software vendor. No licensing cost. 50 TB data we are operating in the community edition with the sharding configuration. Absolutely, our business is scaling. What you lose with the community edition is you're not going to have automated monitor, automated update, okay, automated alerting system, automated tracking system for the system resources and all that. There are encryptions are not available, auditing is not available. So there are certain features are available, not available, but in terms of data processing there is no capping. You can absolutely process the same data what you process in the enterprise edition, in the community edition. So we will do ourselves. DBS will do almost all the monitoring manually with the customized scripts without the enterprise edition. So fourth point I want to stress out is NoSQL products are open source. That's a big point. You don't have to pay anything. Still, it is not capped with any size of your data to operate on the community edition. It will support any amount of data, except the features are locked. Some of the features are locked. You have to get to the enterprise only to get those features, but amount of data you can handle is the same. Enterprise as standard, that something is good. Okay, so there are many points I'm going to discuss one by one. Let's go through the slides now. So NoSQL is not only a SQL database, which is SQL means what? Relational. You divide your data, you keep the normalization, like you divide one table into 10 tables, keep the relation, and you update in one table, it will update in the child table, and child table, if you want to update it, look for the parent table to accept the data. There are many relations. It is very complex architecture when you build a table for any business, in fact, relations and all that. In the NoSQL, nothing, no relation, nothing, non-relational database. NoSQL means actually not only SQL, but you can say that non-relational database systems. No relations, absolutely no relations. within the database, within the table, it is a collection, not a table we say, but in the RDBMS it is a table. Every row is having its own structure. One row does not depend on other row. There is no relation. There is no interdependency between the table to table, database to database. You can't run queries to join two collections here. There is no join statements directly. It won't accept the joins. You don't have a joins. In fact, in MongoDB, you can't join the tables from multiple tables. You have to load the respective data. If I have to keep the data must be within the collection only. You can't divide the data. It has to be within the one single collection only. I'll talk about that in the further classes, how we can make the data locally available within the collection that we have a topic. For now, let's move on. NoSQL means not only a skill or non-relational, whatever you say. Unlike RDBMS, it does not follow the ACID properties to maintain your data consistency. It will follow the eventual consistency. In fact, eventual consistency to maintain the data consistency. We'll talk about that architecture. In the architecture, I'm going to compare what is a ACID property, what is a base property. Basically, eventual consistency. Base means. So they are different things. There is no rollback in Mongo. You have inbuilt commit statement, though it is a loop statement. It is inbuilt commit. In fact, unlike RDBMS. So architecturally they are different. We're going to talk about this better in the RDBM, how RDBM system works, how NoSQL works. I'll explain in the architecture because I'm working on both the products. I'll compare them. I'll show this is there in the RDBMS, this is there in the NoSQL. Every feature we're going to compare and discuss. Compare and discuss. That way it will give you greater insight. Okay. All NoSQL platforms are built for the big data, not for the small amount. No, big data platforms handles large volume of data. NoSQL, all NoSQL will follow the horizontal computing, right? Horizontal computing means it's not limited to small amount of data. It can handle very huge data. That's why we call it as a big data platforms. All NoSQL products handles a big data platforms. Big data, generally they built for the big data, huge data. That's it. These are all for the new generation. New generation means, as I said, if you talk about 2010 before, we were not having a smartphones, not smart tabs, smart devices with anyone. Only phone. That phone also you can make a call, you can receive a call. That's it. You can't do anything with the phone. Now you can do everything. It's a mini computer. You can do everything with your phone. Okay. So that kind of applications what you're using with the smartphones needed this applications needed this kind of database. That's why it is called third generation databases. Okay, it's a new generation databases. New generation only need these databases, not legacy systems. Legacy, they used to feed the data through applications. Now you have lot of apps. Everybody have an app. Everybody is a data generator. Okay, there is no limit on it. So there is no control. So that's why all new generation applications need the your NoSQL platform to accept the data in a semi-structured or unstructured format. Non-relational, I says it's a non-relational. There is no relation between the collection tables within the row to row itself. There is no relation at all. Every row is different. Runs on the commodity hardware, very cheap hardware. You don't have to go with the server class because you are not putting all your data into one system. Okay, you're putting the data into multiple systems. You no need to go to the server class hardware. Too much of costly hardware, you don't need it. Normal hardware also will scale because you are going to keep more and more machines as you grow with more data. So your connections, always one single connection going to multiple systems, it's not flooding one server. So even it is not a server class hardware or cheap hardware, still it scales with the data. That's what it runs on. The commodity means cheap hardware. No need to go to the server class hardware because we are not putting everything into one system. If it is RDBMS, you must have a server class hardware. Hardware itself very costly, the server itself. On top of it, product licensing, right? Product licensing is also required, and that too it's not a cheap product license, very very costly. Every core based licensing model, every product coming with the core based license. How many logical CPU you have, that many licenses you have to pay in the RDB technologies. That is something is a very costly. Open source is another big driving factor. See, Postgres is growing in a lot. Why? It is open source. MySQL is also open source somewhat, not 90-80% functionalities you have in the open source. MySQL is also growing. MariaDB is also completely open source, that is also growing. So people are becoming smart. They are choosing what are the ways they can save the money. So nowadays people are looking for the open source for non-critical systems. Non-critical system is maybe within the company internal applications, maybe non-critical clients, maybe archival data they wanted to maintain, maybe small application they wanted to run on the open source. They are doing a lot of things on the open source nowadays. In every company you have the open source systems. You all are working, right? In every company you are working, definitely you have the MySQL, Postgres, MariaDB, or any of this product. Mandatorily you'll have it. Even including the NoSQL also you're seeing it, right? In every company. Able to enable my mic to talk. Oh, what happened? Someone is not able to talk. You can type it. I can read your question and answer. Just a minute. Who is not able to talk? It's the problem for all. You will rejoin if you have issues. Who is just a minute? Anil, you can rejoin if you have issues. Just rejoin. It'll work for you. Okay. Uh, you can type it if you want. I can read your question and answer. And schemaless, guys. Schemaless means dynamic schema. You don't have to define the schema. I've shown already. It is a schemaless product. You don't have to define the schema at all. It is takes your data dynamically, absolutely dynamically. Then inbuilt data compression. This is so good feature we have in the NoSQL. If you talk about RDBMS, we have a compression, data compression, but you have to do explicitly. If it is SQL Server, because I'm working SQL Server in and out since 18 plus years, SQL Server has two levels of page level, row level. You have to do yourself. You have to estimate it. You have to do which table can be compressed, which cannot be compressed. You have to estimate it first. Then you have to enable the compression on the table level. It's not a database level. It's not a server level. You don't have it. You don't have a technology to compress the entire server. It is a table level, table by table. Whatever the table are bigger, you can compress yourself. But MongoDB is not like that. It compress. If I'm checking the size, all the sizes it is showing is a compressed sizes, not actual sizes. What is the compression mechanism they are using in the background is called, let me show that quickly, snappy compression. I have MongoDB here, log. It will write in the log. So if I read the Mongo log, grep snappy, I'll explain all these commands anyway. I'll give you the entire Linux basics first, and then I start the product. From the next class, all the Linux basics only I'll talk about. You can see the compressor is a snappy compressor. By default, your MongoDB databases are compressed. It will be compressed or not based on what you can say. Data will be compressed based on the duplicates. If your entire data is unique in the entire database, all data is unique, there is no compression. In any product, even in the SQL Server also, compression will happen only when the duplicate data is there within the system. If your MongoDB is having lot of duplicate data, example, I have 30% unique data, 70% duplicate data, 70% will be compressed automatically. So my 100 GB data will show as a 30 GB only. Why? Because 70% of the data is repetitive data. 70% of the data is a repetitive data. That repetitive data will not be occupying the storage. It will compress by default. You don't have to compress. Every collection will be compressed automatically. It is a server level, not database level, not a collection level. By default, server will compress your data if there is any duplicates. This is one big advantage we have in the MongoDB. It compresses your data automatically if you get the duplicate data. Simply, it won't make that storage. It will keep the reference of the same record, and it will call that record reference automatically to give the equivalent data anyway. So compression is a very good advantage we have, because it's going to save lot of infrastructure in the background. High, highly scalable compared to RDBMS we talked about. RDBMS you can write into only one machine, rest are all secondaries. You can read, but write is only one copy, right? One machine in the SQL Server or any other product, except Oracle. Oracle has a rack concept that you can write into multiple servers, but at the end you go to one physical volume. That is a choking point. This is where you lock yourself. You can't write into multiple values parallelly. Here we are writing into multiple servers, in fact. So the highly scalability happens in the NoSQL only compared to RDBMS. Highly available. Even your a chunk of data is down, still you are operational. And also one copy is down, other copy will take the primary role automatically without any external service you have to configure. You don't have to configure anything. MongoDB inbuilt has a auto failover capabilities. In RDBMS, no product will do the automatic failover without the external service support. If it is SQL Server Azure case, no automatic failover without the clustering. Windows do the automatic failover on the SQL Server. SQL Server does not do the failover on its own if you don't have a clustered. In fact, if it is a Postgres server, there is no automatic failover. You go to the third-party tools. Even MySQL, you have to go to the enterprise versions. So third-party service or third service is needed to do the failover in the RDBMS. In MongoDB, no third service required. The product inbuilt capabilities are enough to do the auto failover. That's a great advantage in the MongoDB. I'm working on the 5 different technologies as of now, including MongoDB. MongoDB is really good in many ways, in fact. Many ways. I'll explain that. If you example in any of the database system, if you I remove the system out of the availability, if I join it, it will sync automatically. In any of the RDBMS system, you have to reinitialize the database with a full log and join it. Once you remove entirely from the group, as long as your data is available in the primary, it will sync automatically secondary. You can join with one single command. You can remove the node also. You can join also. That is possible in MongoDB. MongoDB has a very good flexibility in terms of administration. Very good product. It's very interesting product. In fact, when we go step by step, module by module, you really understand it. It is so interesting topic. In fact, supports the base properties instead of asset properties. This is something I'm not going to talk. It's a very important information I have to cover in the architecture. How data recovery happens if the transaction is interrupted in between, it is not written to data file, how it recovers that data, architecture. So it is have a different architecture. We're going to talk about that in the architecture discussions. Mostly whatever the advantages I'm talking, highly available, highly scalable, and these two are getting through the cluster only, through the sharding concept. If it is standalone, you can't get this. You can't get this what I'm trying to talk about. You have a standalone machine, one single machine, one will be down, you're down. You have a replica set. Example, replica set, you have the primary, one secondary, if primary goes down, secondary will take the role. If all are down, down, you don't have this high availability. So if with the help of the sharding only, you can get the more scalability, high availability both possible with the data. Okay, it runs with the cluster to get the all the configurations what I'm trying to discuss. Built for new generation, not for the older generation. These are all new generation databases. In fact, all big data platforms are lately developed and lately adopted products, not since very long. So now, why NoSQL? Just now we were talking about all that. Resolve the challenges faced in storing, managing, analyzing, archiving data. Lot of data you have it, and you can't manage it with the RDBMS. You offload your archiving data into NoSQL technology. Only the business, whatever the data your business needed, that you keep in the live database. It is possible. So how do you convert the SQL data into Mongo data into SQL? You can directly example. Let me show you that. It is something I'll talk about in the future class also, to explain that how data is compatible in MongoDB. Oh, come on, you don't have any data. Let me show you quickly. Or too much of data. It will only support 1,000 records. If you want to convert SQL data into Mongo data into SQL, your data should be less than 1,000 records. If it is more than 1000, you have to go to license tool. There is no other way. So I just want to quickly show. Only I have one record here. This is not sufficient. The heck, let me see. I mean, I want to show you that how we can convert RDBMS data into MongoDB quickly, just for the sake of discussion only. Okay, this is enough. So here SQL data, I want to read for JSON auto. I want to read the data in the NoSQL format. Okay, JSON. So I can read it. SQL data in the NoSQL format. I can read it. The output of the SQL is coming in the NoSQL format. I'll pick this data and to put it into Notepad. SQL data. In fact, this is a SQL data. I read into NoSQL format, JSON format. I'm going to load the data. Okay, db dot student 10 dot whatever it is. Insert many. We're going to see the migration also. A bit of understanding I'll talk about. Licensed tools I can't install and show it to you, but limited data conversion I can show you. So I'll pick up that. I'll run this one. So show collections to find the existing collection student. Now I'm loading this data. This is with student 10. You can see that db.student10.find the SQL data converted into Mongo data. See, whatever the data I had here, I am able to convert your data into. I'll only read this one. This data is converted into Mongo data straight away. You can see that. So conversion is easy, but you can't convert your huge tables by natively. You have to go to the licensed tool only. There are licensed tools. The tools are very efficient. It will convert the data to Mongo, Mongo to SQL, SQL to Mongo. Simple. Few clicks, 2 3 clicks, that's it. It will convert your data automatically. So we'll talk about that in the future. I'll give a fair idea on that. But what I want to convey here is your data is becoming bigger and bigger. You can't handle with the one system. You can convert the data into archived data and keep the limited data in the live database, so that your database scalability will be more. Maintenance also you can do easily, so it is possible. So why NoSQL? Again, explosion of social media sites like Facebook, Twitter, whatever you see, Instagram, everything dealing with the huge data. That huge data cannot be handled by the RDBM systems. Okay, it is handled by the NoSQL only. Simply, need of continuous availability. The more availability you're going to get, because of the lot of systems are working for you, not one. Okay, lot of systems are working for you, giving more availability, more scalability, both together, not one. In fact, need a flexible schema model. So if you talk about Facebook, you upload a video, someone uploading the photo, someone writing the comment, so all are simultaneous, and it is accepting the data. Your comment can be smaller or bigger, even paras you can write it. There is no limitation. MongoDB does not keep a limitation. In fact, it accepts the data how big it is, how the format is, doesn't matter. It just accepts. So that's why need a flexible model. You can't keep in a rigid model. You can't develop everything in the background and load from the front end. It's agile, on the fly. So there, that kind of things will be it can be done here in the MongoDB. NoSQL databases are great solution for growing scale of databases and following the commodity prices. See, data is growing very fast in the market. You look at your phone itself. We used to have in the beginning days, I have used personally my phone. In fact, okay, I have 16 GB phone, 16 GB storage phone. Okay, then 64, then 128, now 256, 512 GB phone we are using it. Still, it is not sufficient. So look at that, how much data we are generating it. So we are evolving with a lot of data. That data is growing in any system. That system, one single system can't scale with this explosion of data. Everybody are huge data generators nowadays, right? So that's something it can't be managed by single system. Okay, that's something you have to go to the cheap hardware to save the money. And also commodity hardware. Cheap hardware is, see, if you look at example, I'll give an example. If you buy a pen drive 10 years ago of 2 GB, We used to pay 1000 to 2000 for 2 GB pen drive, 2 GB. Even I personally purchased. You all know, I guess. Now for 2000 or 3000, you get 1 TB pen drive, 1 TB roughly. So I mean, what I'm trying to say here is the hardware cost is drastically coming down year on year. You compare it. Okay. Now you get 10 TB hard drive. Okay, 10 TB hard drive, roughly maybe 7 8000. 10 TB I'm saying it. So you have the different hardware devices anyway, RPMs and all matters anyway. But what I'm trying to say here is the hardware costs are coming down day by day. The storage hardware cost, especially. So it consists of column-based data. This is something I'll discuss in the next slide. This is not important. Offers capabilities to handle large volume of data. Any big amount of data will be handled. So NoSQL continuous availability, no single point of failure. Even one chunk of one entire 25% of the data, it is not down. Continuously it is available. No entirely downtime. Multi data center capabilities. So in this case, I'll keep two servers in the primary data center, one server in the remote data center in each replica. Even my primary data center completely down, I will have a DR node in the target. Multi data center. It's A data center, there's a B data center. It is possible. Multi data center capabilities we going to see in our class only. I'm going to show you. I'm going to migrate to multi data center. I'm going to show cloud migration also. Cloud VM migration we're going to talk about in our course. Easy replication for distributed location independent capabilities. Very easy, guys. MongoDB configurations are easy. Anybody can do it. But supporting the technology, something need the architectural understanding and the product understanding. If you don't know the product well, you can't troubleshoot the issues well. So architecture is very much important. Configurations are easy. High performance with the linear horizontal capable scalabilities. So it is scaling with horizontally. One request is going through multiple servers horizontally. If it is RDBMS, only one system. You can't run queries on multiple systems for the same data. You go to the same one server, either it is a primary or secondary, doesn't matter. at, at any given point, one server only. That's what is the scalability you are going to miss. Flexibility, schema support, dynamic schema model we talked about. Easy to implement and grow. Very easy. Adding the servers and configuring the servers and configuring the technologies, very easy in the Mongo. Absolutely easy. Only when it comes to the issues, responding to the issues, something is you need to have good understanding. It's an open source community. So these are all great benefits what we are trying to talk since the beginning, right? What are the big benefits? First, open source, high availability, high scalability, flexible schema model. These are all biggest points. And data compression also. Okay, inbuilt data compression also. This is one point I have to mention. Inbuilt data compression. Okay, you don't have to do worry. Then what are the terms we have? So RDBMS, if you talk about rigid schema model, it's a dynamic schema model. We have seen that in practical. I was trying to load the data here where out of definition, I'm trying to load the, come on, where did I have done already. So what I want to show quickly. So if I'm trying to load this data, it is clearly showing you that column name, number of supplied parameters are not matching, right? So that's what, it's a rigid schema. You define the schema, load the data within the schema only. You can't violate the schema. Here there is no schema. First of all, no schema. Everything is dynamic. So vertically scalable. You scale in the RDBMS vertically. You add more and more power to one server only. Here in the RDBMS horizontal, more and more machines we will add for more capability, more processing power. Okay, they are different. Difficult to handle big data. It is good actually. If you talk about Oracle SQL, they are so sophisticated and advanced systems, but they will scale up to certain extent. They can't scale. Okay, when it is growing really big, you can't do the maintenance activities within a given window. If you can't do, you can't scale simply. Mix and open source and proprietary, mostly proprietary. Most of the RDBM systems, like Oracle, MySQL, they are the proprietary. You have to pay and get it. Open source. All NoSQL products are open source. They are data wise, there is no restriction. Okay, you can operate equal amount of data on the enterprise what you can operate. The open source also can operate, but only thing is features you can't get it. Data operation wise you are absolutely capable on both the edition community and enterprise. Mostly standalone, mostly clustered to get the benefits. What we are talking, single point of failure. If I have a database example, like I have a database, I have one data file here, one data file here, one drive is down, your entire database will be down, completely down. Not only entire drive, 10 MB of data is corrupted, you're still gone. So that's how, not a single point of failure, it's a single point of failure. Asset property, base property, I don't want to complete this topic because it is going to covered with the architecture, with the live practical, how recovery can happen. We're going to see that in the NoSQL. Need for server class hardware, costly hardware, need cheap hardware, no need of server class hardware. It is a costly, it is average compared to the cost wise. So types of NoSQL, if you talk about how many NoSQL products we have lot many products like Redis server, Memcached, Scalaris, MongoDB, CouchDB, RavenDB, Big Data, Bigtable, Cassandra, HBase, Hypertable, Infinite Graph. Out of all these, mostly used products are MongoDB. After that, Cassandra. Nowadays, Redis DB also getting used for the cache. So these are the most used products in the NoSQL. MongoDB comes in the first list, then Cassandra, then Redis server. Rest are all not much, but there will be specific companies you are using for specific purposes, not widely used. But out of NoSQL, MongoDB is a growing, very fast growing product as of now. So what is big data? Big data is any data that can be handled, processed through traditional system, but millions of users, millions of queries per second, billions of rows, wide variety of data at the same time. That is called big data. N number of people are calling your systems and they're operating on huge bulk data. Still, they are not really seeing any performance issues. Why? Because your data is distributed, you are reading the distributed data, you're not going to face any issues. Volume, huge data, variety, different type of data, velocity, speed, all are achieved at one point only in the big data platform. All these points are achieved at single point in big data platform only. Okay, that's possible. uh, if it is RDBMS, you have to increase the RAM, increase the CPU, increase the disk in a single server to sustain with the growth of the data. You have to do that, right? You have to increase the power of the system in terms of CPU, RAM, disk space as your data coming in. High costly, downtime, threshold and limitations. If it is going too big, you can't maintain it. A single point of failure, all are disadvantages in the RDBMS. If it is NoSQL, horizontally, more and more servers you keep it, add it, you get the performance automatic. Add more machines, you get the performance. Less cost, no downtime, no limitation, no single point of failures, can be scaled down with any amount of data. So these are all advantages what I want to convey. Next, consistency model. This is something I don't want to pick it now. Let's talk about this, the cap theorem. Then I'll talk about what we're going to cover in our course. I send the course content to all of you in the invite. You can see that this content I have given to all of you. In fact, okay. So let's go through this content at the end of the today's discussion. Fine. Let's understand the what is cap theorem first. Then I'll explain this. This is an interview question. A lot of times you face it. What is a cap theorem, and where does MongoDB fall into all that? So try to understand. I'll explain. Many products. Every product will come into one of the area here. So here you have the cap theorem like this. C means consistency. Okay. A means availability. P means partition tolerance. Partition tolerance means disconnected. Okay. So you can have any product, either AP or CP. What exactly I mean? See, I have the example. I have the MongoDB servers here, three servers. Out of these servers, you have to follow the rule to make the primary n equal to n by 2 plus 1. This is a rule. It's a mandatory to have the primary, in fact. So here availability, partition tolerance are consistency. If example, I have the primary here, secondary here, secondary here. I lost the communication with this, okay, here and here. It is the primary sending the data here, here and here. You lost the communication. So you have a two votes. If you have a three nodes, two votes required. Two machines should be available. Okay. If this is down, still your primary is available. It is accepting the writes and it is syncing the data here. If this is down, then what happens? The primary will also be down automatically. It will be become a secondary and readable only. So it is making sure that if my rule is following, then only I'll accept the write. If your partition tolerance means disconnection, if there is a disconnection between the secondaries with the primary, if it is not seeing the enough voting, then primary will be down automatically. So what it is maintaining is consistency. Whatever I have it, my secondary also should have it. With a at least one of the secondary you must have it. If not, I'll not accept the writes. So it is looking for the consistency. Okay, consistency always. If it is not following the rule equal to the number of voting is not available, the primary will be automatically down. Example, I have a 5 servers, assume a case. I have a 5 servers in the replica group. It is, you can have 50 servers. In this case, you must have 3 servers available. Okay. If this server is down, this server is down, it still write the data. It is syncing here and here. Okay. If third one is down, 3 servers are not available. These two become secondary automatically. It will not let you to write. So when the servers are partitioned, partition means separated or disconnected. When the servers are disconnected in the group, your primary is not accepting the write operations when there is no enough voting. So it is looking for the consistency of the data. It is looking for the consistency, not available. Availability is not looking for, it is looking for the consistency. That's why you have a two nodes still, it is not accepting the writes because enough voting is not there. Okay. So partition means a disconnection of the server. If disconnection happens, what can be done? If you talk about SQL server, even your secondary down, you have A server, B server, B is down, still you write it. You can write it. It follows the availability and partition tolerance. Not MongoDB comes under, MongoDB comes under, come on, CP, consistency, partition tolerance. SQL Server, Oracle Server, all RDBMS will come under AP, availability and partition tolerance. Okay, Postgres, one thing, Postgres will come here especially. Postgres is a one good product. It follows the CP, not the AP in the RDBMS. Especially in the RDBMS, Postgres is one product. It follows the CP. All RDBMS will follow the AP. What I mean, if your secondary is down, still you can write in the primary. It is not looking for that secondary to be available. Okay, you can write in the primary, when the secondary comes it will sync. So consistency, what it says, all copies, at least the minimum copies should be in sync with the primary, then only primary should accept the write. Okay, so this is called cap theorem. You getting it what I'm trying to say here? Yes, no, say something, I'll explain further if you don't get it. This is an interview question, you will get it.
Would you
Okay.
be able to once again, please?
See, there is a rule n equal to n by 2 plus 1 nodes available, then only you can write it. Then only you can write it. No, in MongoDB you have a three nodes. Three nodes means two nodes should be available to write the data. Two secondaries are down, primary will become secondary automatically. It will become secondary automatically. You can't write, you can't write at all into the primary because primary did not get the enough voting. It is not accepting because it is following the consistency model. My data should be consistency across the machines, other machines also, as long as my voting is available. Okay, if I have a 5 nodes, 3 nodes are down, 2 nodes will become secondary automatically. It's getting to right because it's looking for the consistency. with the n equal to n by 2 plus 1 rule, always. If it is RDBMS, you have A server, B server, B server secondary is down, A server still you can write the data, writing. So you are available, though your secondary down. Down means you are partition tolerant. It is disconnected. Still, you are looking for the availability, not for the consistency. Consistency means you should have the same data on the secondary also. Then only you accept the data. Getting?
Got it.
So that's what RDBMS products, except the Postgres, will fall into AP model, and MongoDB will fall into CP model, consistency and partition tolerance. Because in the case of n equal to n by 2 plus 1 is not actually satisfied, then you have to go to the secondary only. Primary will not accept the transaction.
I know you're going to show this later as well, but just out of curiosity, how does it maintains the votings actually? Does it uses anything native to Unix or something?
It will poll internally. There is a polling every 10 seconds. It will happen. It will write the log also. It is polled and received the acknowledgement.
So
Polled
it,
and
it,
received
it, it is internal to
internal.
MongoDB then. Okay,
Yes, within the Mongo. I'll show that. We're going to discuss that.
sure. Thank you.
Okay. Coming to the module content, what we're going to discuss. I'm going to cover all the Linux basics first. All. I mean, whatever a DBA should know, what level of knowledge you must have as a MongoDB DBA or Postgres DBA or any DBA. This knowledge is going to be enough. I'm going to cover all the Linux basics. Then we will go to the architectures. Then we will go to the CRUD operations. CRUD means deployments. You do the deployment, right? Before you do the deployment, you have to review it. To review it, you should know the how to review it. So for that, I'm going to spend 2.5 classes how to review the deployments. First, I'll cover all the coding side. Anybody can understand. Don't worry. Anybody can understand. I have a lot of experience in teaching also, even working also. So I'll share you with the, like, peeled banana. You will have a ready-made knowledge. It's my guarantee. You just attend my classes. You will be more comfortable than whatever the product you are working on right now. I'll make you that level for sure. I'm not exaggerating. You will get to know. As CRUD operations and schema design, this is a development part. I'm going to discuss development because we're going to support it. The schema validations we have to support. When we do the deployments, we will go through a lot of issues when the schema design is done. So how you bypass that? How you really handle that? The deployments when they have a schema design. So this is one class I'll explain. This 2.5 classes, roughly 4 classes on the development side itself to make you understand. First, I'll show how this will be done as part of the development. Then as part of a DBA, what do we do? In fact, to support that kind of things, I'm going to show clearly. Then rest of the topics are Linux based, so product based. You can see the description about every module I have defined. You can see that one by one module. Everything what I have written is going to be covered in detail. So I have added few extra things for this batch. Enterprise features. Did I write enterprise? Right, enterprise. Enterprise features I did not talk about in the previous batches. And the sharding security implementation also I did not talk about in the previous batches. There is a 3 to 4 hours content I added to this batch. You are lucky, in fact, to get those new content into this batch. Okay. So anyway, that's okay. It's good that you're getting compared to other batches. This batch is going to be little extra, at least 3 hours, 3 to 4 hours content extra. Okay. So this is all for today. So any questions before I stop the video? Just stay back. I'm stopping the video. But if you want to ask, you can ask something. Right. So now